Good day to all of you, especially to our instructor, Mrs. Josephine Gonzalez. Our topic is all about nomenclature of inorganic compounds. This is a report of Group 4. Joanna Rose J. Dangani, Regency Deza, Eileen A. Adan, Glyza C. Labrador, and Baby Christine Dahero. Nomenclature is the process of naming chemical compounds with the different name so that they can be easily identified as a separate chemical. Inorganic compounds are compounds that do not deal with the formation of carbohydrates or simple all the compounds that do not fit into the description of an organic. Let's talk about binary compounds containing the nonmetals. In materials chemistry, a binary phase or binary compounds is a chemical compound containing two different elements. Some binary phases compounds are molecular carbon tetrachloride. More typically, binary phase refers to the extended solid. Here are some examples of binary compounds containing two nonmetals. CO stands for carbon monoxide, CO2 carbon dioxide, CC14 carbon tetrachloride, CO2 sulfur dioxide, and N204 dinitrogen tetroxide. Are some rules for naming binary compounds containing two nonmetal. Number 1. The second element has the ending IDE. For example, carbon monoxide. The last letter in the carbon monoxide is IDE. Rule number 2. The number of atoms of each element is indicated with the Greek prefix. In the case of nomo, it is only used for the second nonmetal. When no prefix appears, one atom is assumed. Number 3. If two vowels appears next to each other, this vowel from the Greek prefix is dropped. This is for the case of pronunciation. For example, you will see in this page or
So 6.2 binary compounds containing metal and non-metal. In binary compounds, it has a metal and non-metal components. Metals combine with non-metals to give ionic compounds. When naming binary ionic compounds, name the cation. Cation is a positive charge ion. Example, one that would be attracted to the cathode on electrolysis. First, specifying the charge if necessary. Then, the non-metal anion element is stem, the non-metal and metal signs. Example, it said in this statement, when a metal such as a sodium combines with a non-metal such as chlorine, the resulting compound contains ions. The metal loses one or more electrons to become a cation, and the non-metal gains one or more electrons to form a anion. It said that if the non-metal or the anion was 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 transferred to the other elements, it will create another components. The resulting substance is called a binary ionic compound. So anion is a electrolytes. Binary ionic compounds contains a positive ion cation, which is always written first in the formula, and the and a negative ion or anion. To name these compounds, we simply name the ions. So in this image, you will see the example of, in the left is the metal and in the right is the non-metal. Other metal atoms can form a two or more cations. For example, carbon can form a carbon 2 and the metal sign, and carbon 3 and the metal sign. And the Cu or copper can form a copper metal sign and copper 2 metal sign. We will call such ions type 2 cations and their compounds type 2 binary compounds. In summary of all of these, type 1 compounds, the metal presents forms only one type of cation. Type 2 compounds, the metal present can form two or more cations that have a different charges. Some common cations in anions and their names are listed in table 5.1. So this is the table 5.1 presenting the example of common simple cations and anions. A simple cation has the same name as its parent element. Rules for naming type 1 ionic compounds. Number 1, the cation is always named first and the anion is second. A simple cation obtained from a single atom takes its name from the name of element. For example, Na and the metal sign is called sodium in the names of compounds containing this ion. Number 3, a simple anion obtained from a single atom is named by taking the first part of the element name, the root, and adding IDE, example, monoxide. Thus, the Ci ion is called chloride.
Binary acid. Acid are hydrogen-containing compounds that yield hydrogen ions, H plus in the water. Binary acid are acid that consists of two elements, one of the elements hydrogen-containing compounds. As the pure compounds, example, in the gaseous or liquid state, they have a different properties than they do in aqueous solution of the compounds. The rules for naming the acid in aqueous solution. Here are some example of binary acid. HBr stands for hydrogen bromide. HF hydrogen fluoride, and H2S stands for hydrogen sulfide. There are some rules for naming binary acid. Number 1. The pure compounds, example in the gaseous or liquid state, start with the hydrogen, followed by the anion name ending with IDE. Second, as the aqueous acid solution, start with hydrogen, change the anion name to the end with IC, and add the word acid at
6.4 Tertiary and higher compound. What is a tertiary and higher compounds? A tertiary and higher compounds develop all kinds of shorthand phrase to describe structure and phenomena that might in organic chemistry. Tertiary compound is a containing three different elements. Example are sodium, phosphate, Na3, and PO4. A tertiary compound in which hydroxy group OH. It is attached to saturated carbon atom which has the other carbon atoms. What is tertiary reaction? A tertiary circular reaction emerges towards the ends of the centrilomotor stage about beginning of differ from earlier behavior for the develop. According to the James Ashenhurst, there are the three tertiary reactions. First is primary, secondary, and tertiary chemistry. Primary carbons are attached to one another carbons, hydrogens, although usually in terminology as we shall see. Secondary carbons are attached to two other carbons. Tertiary carbons are attached to three carbons. Tertiary is a term used in organic chemistry to classify various types of compound alcohol. 6.6 is all about formula writing and chemical nomenclature. Nomenclature be at collections of rules for naming things and it is important science and many other situations. What is the purpose of chemical nomenclature? A chemical nomenclature is a set of rules to generated systematic name of chemical compound. The nomenclature is most frequently worldwide, is the all created and developed by international unions of pure and applied chemistry. What is the purpose of chemical nomenclature? The main purpose of chemical nomenclature is to identify chemical species by means written or spoken. Formula are combinations of symbols that represent compound. A formula indicated which elements are involved and number of atoms of each element contained in the compound.
6.5 Valencies of common elements bond radicals. What is valency? Valency is a radical chemical special that has an unpaired electron, whereas valency is a chemical concept that describes the ability of a chemical element to combine with another chemical element. What is valency radicals? The valency of radicals is always a whole number. Elements or radicals with valency 1 are monovent, those with valency. All nonmetals and non-metallic radicals have negative valencies as shown in the table below. The valency elements chemistry. Table element valencies. You can see it in the slide. And another brief story. The word valence was described in 1452 with the Latin word valentia, which means strength or capacity. The concept of valence was developed in the half of the 19th century to explain chemical bonding and molecular structure. The theory of chemical valence was proposed in an 1852 paper by Edward Frankland.
6.7 Rules in formula writing and naming compounds. A chemical formula is also called molecular formula. The symbol in the molecular formula tell us about the elements and the subscript tell us how many atoms of that elements are present in one molecule. Rules for writing a chemical formula. First, write down the symbols of the elements or ions which combine to form a molecule of the compound side by side. While writing the formula of a compound containing a metal and a non-metal, the symbol of the metal is written first, followed by that of the non-metal. Two metals do not join up to form compounds. Second, write the valency of each element or ions. Third, interchange the valencies of the elements or ions and write as the subscript. Write them close together and ignore one to obtain the formula. Fourth, the radical or polyatomic ions must be written in brackets before the subscript is written. In case the number of polyatomic ion is 1, the bracket is not required. Fifth, whenever applicable, write simple ratios of the valencies. And last, the final formula must be written without any sign of the charge. Naming compound. There are 5 compounds, which is ionic compound, molecular compound, acids and bases, hydrates, and familiar inorganic compound. Naming ionic compounds. An ionic compound is named first by its cation and then its anion. In chemistry, an ionic compound is a chemical compound which ions are held together by ionic bonds. Usually, the positively charged portion consists of metal cations and the negatively charged portion is an anion or polyatomic ion. Ionic compounds are high melting and boiling points, and they tend to be hard and brittle. Naming molecular compounds. Molecular compounds are named using a systematic approach of prefixes to indicate the number of each element present in the compound. Naming acids and bases. Naming acids. Acids are named by the anion they form when they dissolve in water. Depending on what anion the hydrogen is attached, the acids will have different names. Naming bases. Most strong bases contain hydroxide, a polyatomic ion. Therefore, strong bases are named following the rules for naming ionic compounds. Naming hydrates. The name of a hydrates follows a set pattern. The name of a ionic compound followed by a numerical prefix and the suffix hydrate. Inorganic hydrates. Hydrate is a term used in organic chemistry and organic chemistry to indicate that a substance contains loosely bonded water. Organic hydrates. In organic chemistry, hydrates tend to be rarer. An organic hydrate is a compound formed by the addition of water or its elements to another molecule. Naming familiar inorganic compounds. Familiar inorganic and organic compounds are often known by their common or trivial names. Common names versus systematic names. Common chemical names are used in spoken or informal written communication by chemists. For some simple compounds, their systematic and common names are the same. General practices and naming. The general practice among chemists is to use the more common chemical names whenever it is practical to do so, especially in spoken or informal written communication. Many of the common names are known and used mainly by the scientific community. Chemical substances that are employed in the home, the arts, or in the industry have acquired traditional or popular names that are still in wide use.